Hello everyone. Today we're going to look at something called the Euclidean algorithm. But first, we're going to look at how to create and use a Java method. So I have here, basically all I have is a main method here. I'm going to go down outside of the main method and I'm going to create a Java method. So to create a method, I'm going to start with public static, and my method is going to return an integer. So I have integer here. My main method has a void, means it's not going to return anything. This method here is going to return an integer, and I'm going to call it scan. So it's basically going to scan in an input from the user, and it's going to be an integer input. I'm going to have an input parameter called s, and it's going to be a string. So it's taking in a string from the program. Wherever it's calling it, it's going to pass in a string. So here I'm going to declare a scanner variable sc equals to new scanner, and it's gonna take the input from the console. So it's system.in. And I'm gonna declare a variable, integer variable, I. I'll initialize it to 0. That's gonna be my return variable. Now I'm gonna prompt the user. So basically I'm just gonna display on the screen whatever is being passed into me. It's being passed in this variable s. I'm just gonna print it, and that's gonna prompt the user to enter an integer. I want to make sure it's an integer, so I'm gonna test if the input has an integer entered. Has next int. Then I'm gonna set my I variable equals to that integer number entered. So now if there's an integer entered, I'm gonna set I equals to that, and all I'm gonna do is I'm gonna return my variable I. Let's put it inside of the method here, not outside of the method. So I'm gonna return I. And there's my scanning method, which is gonna take in the string, display the string on the screen, read in an integer that the user entered, and return it. Now, so that's how you create a Java method, and we're going to see how to use it in this main method right here. Before we get to that, let's go over this Euclidean algorithm. So basically, this algorithm gives you the greatest common divisor of two numbers. So if you enter two numbers, you follow the algorithm, you can get the greatest common divisor. You can also use it to reduce any fraction to its simplest form. So if you have a fraction, you want to reduce it to the simplest form, you can use this algorithm to get the smallest possible fraction. Okay, so what the algorithm says is, given two numbers, a, let a be the greater number, let b be the smaller number. If you take a divided by b, it's going to give you a remainder. Store that in the variable r. Now, if r is 0, then your greatest common divisor is b. So when r is 0, b is your greatest common divisor of the two numbers. If r is not 0, you go to the else here. If r is not 0, you're gonna set a equals to b equals to r, and then you go back up here and repeat the process. Alright, so let's get started to see how we can implement that in Java. So first I'm gonna declare a few variables here. I'm gonna have integer OA equals to 0, so I initialize it to 0, and this is gonna be this is the original input, and it's gonna be used for the fraction to calculate the simplest form fraction. So this is gonna be used for displaying the fraction. Alright, so that's one number. I need two different numbers, so I'm gonna have OB also initialized to 0. That's gonna be the original input from the user, and it's gonna be used to display the fraction. Next, I'm gonna need a few more integers. So I'm gonna have integer a, b, r, and maybe a temp variable, temp t. So I have four more integers. ab I'm gonna use to store these ab, r, and a temp variable I'm gonna show you what I'm gonna use for later. Alright. Next, I just wanna display a message to tell the user what this program is gonna do. So I'm gonna say this program will calculate the greatest common divisor of two numbers entered. Okay, and I want to skip to the next line. Let's see what else we want to tell the user. The system will also give you the simplest fraction form. Will also give you the simplest fraction form. And also skip to the next line. Alright, and that's all. So now what I want to do is I want to read in the first number. So basically I use my original variable here, original a. I'm gonna set it equals to my method here, my scanning method. So it's gonna be scan, and then the method takes in a string, so I'm gonna pass in a string, which is gonna be my prompt. So I'm gonna say enter an integer greater than 0. Alright, so that's gonna prompt the user, and my message is coming in as a string here. It's gonna prompt the user, and if the user enter an integer, it's gonna store it in I, it's gonna return the I. The I is then gonna be placed into this variable OA. So OA is gonna have the value of I, which is the value that the user entered. So I just wanna do some error edit checking here in case the user, even though we tell the user to enter an integer greater than 0, but what if they don't listen, they don't pay attention, and they enter like a 0 or a character that is not an integer. So I don't want my program to crash. So what I want to do is I want to put in a checking. So I say while OA is less than 1, I want to keep on asking the user to enter another number. So if OA is less than 1, meaning that the user has not entered an integer, because if they have entered an integer, then I would store it into I. If they have not entered a valid integer, then I would be 0 and 0 would be less than 1, and this while loop is gonna keep on asking the user to enter an integer greater than 0 until it finds a valid integer entered. So then when we get a valid number, then we have the first integer. Now we need, for this algorithm, we need 2 different integers. So I'm going to do the same thing for B. Enter, and I'm going to change my message a little bit. Enter another integer greater than 0. So that's the beauty of using a method, is you can keep on calling it over and over again, and you can pass in like different value into the method without rewriting the code over and over and over again. Alright, so I'm gonna ask it to enter another method. So now when that's done, when it exits the while loop, meaning I have 2 different integers, next thing I want to do is I want to place the smaller number in the numerator, because this is going to be part of a fraction, right? So the smaller number goes in the numerator and the larger number goes in the denominator. So I want to place smaller number in the numerator. Alright, so I'm just gonna have an if statement. If OA is greater than OB, OA is the first number the user entered, OB is the second number the user entered. So if the first number is greater than the second number, I'm gonna use my temp variable here, and I'm gonna set that equals to the first number, and then I'm gonna set the first number, which is OA, equals to the second number, which is OB, and then I set the second number, which is OB, equals to my temp variable. So basically I'm swapping the number. I have a typo here, OA, not AO, and I need the semicolon here. Alright, so swapping the number. If A is greater than B, I want to swap. I want to make A the smaller number and B the greater number. And now that's going to be used for my fraction, to calculate the fraction. And now I can get started with this algorithm. So what we want to do is we want to set A, let A be the greater number, B be the smaller number. So A is gonna be equals to OB, because here we are making sure that OB is the greater number, right? So A is gonna be the greater number is OB, B is gonna be the smaller number, which is OA. And now we're gonna have to keep looping until we get a 0 remainder. So we have to keep dividing A over B and get the remainder until the remainder is 0. So to do that, I'm gonna have a do loop. So we're gonna implement the Euclidean algorithm. And we're gonna do that with the do loop, a do while. Do while the remainder is not 0, not equal to 0. Alright, so while the remainder is not equal to 0, I'm gonna keep on doing this. So here inside the loop, what we're gonna do is we're gonna calculate the remainder. So to calculate the remainder, I'm gonna use the modulus operator, a modulus, my percentage sign, a modulus b. Okay, that's gonna give me the remainder. Now I need to do the next step. So I just did this part right here. I need to check if the remainder is 0. So if the remainder is not 0, not equal to 0, then I want to do this part here. I want to keep replacing the variable and check the remainder again. So if the remainder is not 0, I want to do a equals to b and b equals to r, right? Remainder is not 0. We want to set a equals to b, b equals to r, and repeat the process. The while loop is gonna repeat the process for me. So after I set this, it's gonna go here, it's gonna go back up, and now I have my brand new a and b variables, the values. Then I calculate r again, and then I check r to see if it's 0 again. So it's gonna keep on doing this until r is 0. When r is 0, it's not gonna do this if, and it's gonna exit this while loop. So now I have my greatest common divisor. When it exits the loop, my greatest common divisor, it's gonna be the variable b. If r is 0, then greatest common divisor is b. So that's gonna be the value of b. So let's print that. Greatest common divisor. Okay, greatest common divisor. I'm just gonna call it GCD is, and it's the value of b. And the other thing that we want to show is we want to show the simplest fractional term. So here we're gonna say simplest fraction form is, I'm gonna copy this, paste, simplest fraction form is, and that's gonna be let's see, that's gonna be our original variable, which is OA. So I want to take OA, divide by B, over OB over OB divided by B. So that's gonna give me the simplest fractional form. Simplest fractional form is, okay, so OA divided by B, you're dividing the numerator and the denominator by the greatest common divisor, you get the simplest fractional form. I think everything looks good. Check for errors. No errors. Okay, let's run it. Alright, this program will calculate the greatest common divisor of two numbers entered. The system will also give you the simplest fractional form. Okay, let's run it again. Simplest fractional form. Enter an integer greater than 0. So I'm gonna test my program by just hitting enter. It doesn't do anything, it doesn't crash. I'm gonna try and enter a 0, so which is an integer not greater than 0. And then the program asks me again. I'm gonna try enter a -1. It asks me again. If I put in a W, ask me again until I put in a valid integer. So let's try 25, and it took it. Now it asks me enter another integer greater than 0. If I put in a P, let's say, it asks me again. So let's put in a valid integer, 15, hit enter. Alright, greatest common divisor is 5, because both 15 and 25 is divisible by 5, and the simplest fractional form is 3 over 5. So if you have 15 over 25, you divide 15 by 5, you get 3. Divide 25 by 5, you get 5. So 3 over 5. So that's how the program works. Let's try another run. This is fun. So let's say it's 370 is my first integer, and how about 175 is my second. So this is kind of tough. Like, I wouldn't be able to do this by hand. Again, greatest common divisor is 5, and the simplest form is 35 over 74. If I take a calculator, I may be able to calculate that. Let's try one last one. First number, let's say 239, because I don't want a 5 anymore, so I gotta pick a different number. And the second number, let's say 933. Oh, greatest common divisor is 1, 239, and 933. So they cannot, there's no number they can divide by the two of them. Interesting. Alright, you can, of course, verify it with a calculator, but that seems like it makes sense.